Welcome back to my YouTube channel. I'll be showing you how to solve inverse of a differential function, because this is purely different from the normal inverse, which I guess you know. So I would like you to pay attentively to what I'll be showing you now. Okay, we have three questions: y equals to sine inverse of x, y equals to cos inverse of x, and y equals to tan inverse of x. So I'll be taking them one after the other. So for the first one, y equals to sine inverse of x. Now if we choose to rearrange this thing, just like saying sine y equals to x, sine y is equals to x, sine y is equals to x. That's assuming we are asked to find this angle, and this is the given. So we take the inverse of s. That's it. This is just, we decided to rearrange it. Rearranging it, we get the sine y equals x. Then this is the original question. So with this we are good to go. Then differentiating, we have that if we differentiate the x with respect to y, we have cos y. As differentiation of sine will give us cos. So taking the inverse, which is, sorry, not the inverse, that's putting it like this, the y and the x, that's making, and let's say making the y subject formula now be, the y subject formula will now be 1 over cos y. Making, that's not just making the y subject formula, but we often make bringing the y to be up, something like that. I don't know if you get what I'm saying. That's, here we have the s is over the y, but here we want to make it the y over the x. So we now take the inverse of this one, which will now be 1 over cos y. 1 over cos y. That's what we got here. So we have that the answer at this point is 1 over cos y. But in trig functions or trig identities, we have that cos square s plus sine square s is equals to 1. So making cos square s subject formula, and cos square s is equals to 1 minus sine square s. Because this is enough square, now we'll remove the square here. So we have that cos s is equals to 1 minus sine square s, all in square root. So here is y now, so we substitute x for y. So we now have that dy dx is equals to 1 over 1 minus sine square x, all in square root, y minus sine, all in square root. So this is what we got. But because we are using y, so we should change this to y. But from our previous statement or equation, we have that sine y is equals to x. So our dy dx will be 1 over 1 minus sine square x square y, sorry, all in square root, and divide the s will be 1 over 1 minus s square. That's, since we know that sine y is equals to x, then sine square y will be s square. So same thing with this, sine square y will now be s square. So this is the inverse of this function, y equals to x, y equals to sine inverse of x. So the same thing with y equals to cos inverse of x. Cos y will be x, the x dy will be minus sine y. As we differentiate cos, we get minus sine. So dy dx is equals to 1 over minus sine y, which is equals to minus 1 over sine y, because in differentiation our denominator will never have a negative sign, so we bring it up. So dy dx will now be minus 1 over 1 minus cos square y all in square root. Taking this pattern, here we have that cos square s is equals to 1 minus sine square s. So looking for sine square s will now be 1 minus cos square s. So now dy dx equals to minus 1 over 1 minus s square all in square root. So our dy dx will now be minus 1 over 1 minus s square all in square root. This is our inverse and the answer. So the third one is y equals to tan inverse of x. So taking the same procedure, you have that tan y is equals to x, and the x dy is equals to, if we differentiate tan y, we have sec square with respect to y, it's a square y. So dy dx is equal to 1 over sec square y. So this is what we have, 1 over sec square y. Over sec square y. So differentiating, we have that from the trig identities, sine square x plus cos square s equals to 1, then dividing all by cos square s over cos square s, then over cos square s. This comes sine square s over cos square s is equals to tan square s plus 1. 1 over cos is equals to sec square s. Because we have cos square, to now be sec square x, So sec square x equals to 1 plus tan square x. This and this are the same thing, both of them are the same thing. We now have that dy dx from what we got previously, dy dx equals to 1 over sec square y. So dy dx equals to 1 over sec square y, which is equals to 1 over sec square y. Is because we are using y now, so whenever we see s, we put y. 1 plus tan square y. But tan y is equals to x, so wherever we see tan y, we put x. Wherever we see tan y, we put x. Therefore from here now be dy dx equals to 1 over 1 plus s square. That's tan y is equals to s, so tan square y will be s square. So dy dx equals to 1 over 1 plus s square. This is the inverse. So these three are the inverse of each of the differential equation of the function. So the function given y equals sine inverse of x. We have that the inverse is 1 over 1 minus s square all in square root. Y equals to cos inverse of s. We have that the inverse is 1 minus 1 over 1 minus s square all in square root. And the inverse of y equals to tan inverse, y equals to tan inverse of x. The inverse will be 1 over 1 plus s square. So with this, we're able to achieve three things. That's to get the inverse of these three functions given. So I believe you understood what I just taught you now. And I will implore you to hit the subscription button and the like button. Once again, thank you for watching. See you.